Hello, and welcome to day 11 of ATMOS 2750. We are done with the air quality module, and we are moving on to the energy module. Today we're going to do part one of a two-part presentation. We're going to be reviewing world energy. We're going to look at overall trends, look at how those trends vary regionally, and then focus in on the world use of oil and natural gas, and what the reserves of those are, and whether or not they're exported or imported at different places around the world. So where am I getting my data from? I'm actually getting my data from the British Petroleum Statistical Review of World Energy. The link for that is down below, and I'll publish that in Canvas as well. Why am I using a publication from oil industry? Well, in part because they've been doing this a really long time using the same methodology. BP's been doing this for more than 70 years, and you figure that a oil industry probably really wants to know how energy is being used around the globe so that they can plan ahead for changes in the market and that they can best optimize their market strategy. As we start to move towards renewables, they want to have a really good idea of where things are at around the world and how much is available. That being said, I just learned that this is going to be the last year that BP actually is doing the statistical review of world energy, and they're turning this over to a nonprofit that has expressed an interest in doing this. BP claims that they would prefer to use the resources that go into this so that they can better plan for renewable energy in the future. What we're looking at here is if you just look at the dark green, we're looking at the economic activity and its contribution to the carbon dioxide in the atmosphere, the change from year to year. So anything that is above the zero line means that we were emitting more carbon dioxide to the atmosphere than in the previous year. And you'll see that over this 15-year period, the annual change in carbon emissions is positive in all but 2 years. And those 2 years have something in common. 2020 was the pandemic, of course, and we had economic recession that reduced the productivity. And then we had the same thing going on in 2008, 2009, where we had the housing crisis, and that led to a global recession. So that's essentially the economic driver of CO2 emissions. But generally speaking, we're still emitting more carbon year after year. Part of the story is where we're getting our electrical power from, and the total amount of energy that's being produced by electricity is still dominated currently by coal and natural gas. Together, those two sources of energy make up about 60% of our electrical power production, with renewables, specifically wind and solar, making up about 13%, but the 13% is growing exponentially. And this chart doesn't show nuclear and hydropower, which make up the balance for the amount of electrical power that we actually generate each year. If we look at the world consumption of energy for all purposes, not just electricity, you'll see that we're clearly using more energy now than we were 20 years ago. In fact, back in the year 2000, we were using about 400 exajoules. That is a lot of energy, by the way, and that has increased over that 20-year period up to about 600 exajoules. And what that means is that we are using about 50% more power or more energy than we were just 20 years ago, which is actually quite frightening. Part of that is population growth, and part of that is development in certain countries around the world. Standard of living is going up, and as standard of living goes up, so does the energy requirements. So where are we getting this energy from? It's kind of actually scary. If we look at the green, which is oil, the red natural gas, and the gray, which is coal, together, those make up about 500 out of the 600 exajoules of energy that the world uses. So that means 5/6 of all of our energy is coming from fossil fuel, with the balance being from nuclear, hydro, and renewables. And of course, on this, you can see the dips in 2020 and 2009. Even though it's labeled incorrectly on the bottom, it says 19. It's actually supposed to be 09. So let's take a look at what's going on in terms of the share of the global primary energy. So the first thing to note is that our reliance upon oil as the primary energy source of the planet is decreasing. In 2000, we had about 40% of our energy coming from oil, and that's decreased now to just about 31%. The other thing that's decreased is nuclear power. It's decreased from about 7 to 5% of world power. And coal was rising up until about 2012, and then it's now started to decline. So if you have some types of energy that are in decline, you have to be making up the difference from other sources. So there are two sources that are basically making up the decline in oil, coal, and nuclear, and that would be natural gas, which is the red line, and renewables, which is the kind of orangish, reddish line that's starting to increase from near zero in 2000 to about 7% in 2021. The other thing to note is the blue line, the hydroelectricity, is relatively flat. We're not building new hydro facilities around the world for the most part, so it hasn't really changed that much. If you look at things on a regional pattern, you'll see it quite different. On the bottom x-axis here, we have North America, South and Central America, Europe. We have CIS, that's kind of the old Soviet bloc countries, including Ukraine and Kazakhstan and some of the other countries around there, Turkmenistan. We've got the Middle East, we've got Africa, and we have Asia Pacific, which includes China and India. For North America, you'll see if you add up all the fossil fuel sources, the oil, green, the natural gas, red, and the coal, gray, it makes up about 80% of the energy consumption in North America. And you'll see we have, about 7 or 8% nuclear, 7 or 8% renewables, and a little slightly less than that for hydro. The big difference for Central and South America is they have a lot more hydropower, and they also have more renewables than we have. So that but they also have almost no nuclear. So their reliance upon fossil fuels is only about 65%. If you look at the old Soviet states, the CIS, they are heavily reliant upon natural gas, less so on oil, and less so on coal. Middle East, they pretty much rely on oil and gas. That's what they have in abundance, and they don't really invest in anything else. And lastly, when you get to Asia, you can see that Asia is heavily reliant upon coal because that's what they have in that area. Less reliant on natural gas, and they have significant investments in hydro and renewables as well. So if we look at the energy use per person for different regions, for North America, you'll see that over the entire time period from 1987 up through 2020, people in North America use more energy per person than any other continent. The second most would be the old Soviet states, followed by the Middle East, and then Europe. Down at the bottom of this is Africa, which is very resource poor, and energy use per capita is about 10% of what a person in North America actually uses. So let's turn our attention to oil. So what this is the reserve to production ratio. And what that means is we know how much oil we have in proven reserves in the ground, and we know how quickly we are pumping it out of the ground. And you just do a division, number of years that you could actually pump that resource out before it went dry, assuming that you don't continue exploring and finding new sources. And for North America, we have about almost 30 years worth of reserve to production ratio, which means that if we didn't do any additional exploration, that we would run out of oil in North America at the current rate of production in 30 years. Europe, in contrast, only has less than 10 years worth of oil in the ground. Asia Pacific, China, and that area has about 15 years of reserve to production ratio. The Middle East, which is resource rich, has almost more than 80 years worth of oil that they can extract, and South and Central America has 150 years. And that's a little deceiving because they just recently found some really large oil reserves, and they haven't yet ramped up production. When they do ramp up production, it will reduce the reserve to production ratio for that region. And you can see that here in this plot, which shows the history of the reserve to production ratio. So that dark green line basically shows that South and Central America had a reserve to production ratio of about 40 for a long period of time, and then it dramatically increased to 120, and then with a new discovery of oil and then a secondary discovery pushed that all the way up to 150. The Middle East, which has pretty much been pumping and not exploring, they're slowly declining in terms of their reserve to production ratio. If you look at the light green, which is North America, we had a reserve to production ratio of about 25 years for a while, and then we had a jump because we had a significant oil discovery that pushed our reserve to production ratio up beyond 45, and then it's slowly been decreasing now as we're pumping that out, and we're now down below 30. That big oil discovery that we had there in the late 1990s was the Gulf of Mexico. Oil that was underneath the Gulf of Mexico on the continental shelf. And overall, for the entire world, we have a reserve to production ratio of slightly more than 50 years. So here we can see how much oil we have in proven reserves as a function of a decade, and we can also look at where that oil is located. So let's start off on the left. For the year 2000, the total amount of oil in proven reserves at that time was, I love this unit, 1,300,000 million barrels. Well, 1,000 million is a billion, and 1,000 billion is a trillion, so it would have made more sense to me if they just said that this was 1.3 trillion barrels of oil. And of that 1.3 trillion barrels, more than half of it was actually located in the Middle East. Flash forward to 2020, the Middle East still has almost half of the proven reserves in the world, and the total proven reserves has gone from 1.3 billion to 1.3 trillion to 1.7 trillion barrels of oil. The big difference in terms of the makeup is that the South and Central America went from 7% of the world proven reserves to 18% with those big oil discoveries off the coast of Venezuela. If we look at the oil production by region versus the oil consumption by region, you can kind of get a feel for who are net importers and who are net exporters. If you start off with the light green, which is North America, we pretty much are producing about the same amount of oil that we are consuming. I believe that we are slightly positive in that we're slight exporters of oil, but the data will tell. Then you look at Europe, and Europe doesn't produce that much oil. They burn a significant amount, and they are net importers. South America exports more than they actually use, and then you get to the Middle East, and they're definitely exporting more, and Asia Pacific is definitely importing more. So oil consumption per capita is actually dominated by the developed world, and specifically Canada, the US, much of Europe and Russia, Saudi Arabia, of course, where they have lots and lots of oil, and Australia, New Zealand, with also South Korea and Taiwan. So developed countries tend to use more oil per person than lesser developed countries. So where's all that oil being moved around? And how do you move oil around? Well, you can move oil around by pipeline. but there aren't many really long pipelines for oil. We're going to talk about some examples of that, including the Trans-Alaska Pipeline, which goes all the way from the North Slope of Alaska all the way to Valdez in the southern part on the Gulf of Alaska. But most of this transport is actually done by oil tanker, by ships. And if you take a look at the Middle East, specifically kind of the Saudi Arabia area, all arrows are kind of leading away from Saudi Arabia because they're providing oil for other countries. Where is a lot of that Middle Eastern oil going? Well, a big chunk of it is going to China, 277 units here, and the units are millions of tons. 130 of that is going to India, and they're sending about 207 of that down towards Indonesia, including Australia. Some of that's going to Europe, some of it's going to Africa, and a small amount of that actually makes it to the United States. Only 21 units, though, of million tons. So when it comes to the United States, we are importing and exporting. We tend to import oil and export refined products. So you'll notice that we're importing oil from Venezuela, and we're exporting essentially kind of gasoline and jet fuel and that sort of thing back to South America. We are likewise importing oil from Canada, from the Athabascan tar fields up in Alberta. And then we are also getting some oil from the North Sea over near England that is being transported over as well. Let's switch to natural gas. Natural gas occurs along with oil. So the same geologic features that trap oil can also trap natural gas. And in North America, we have been using fracking to increase our natural gas reserves, and our natural gas reserve to production ratio is still less than 20 years, as is Europe's. The Middle East, which largely hadn't been using the natural gas and had been pumping it back down into the oil fields, still has more than 100 years worth of production for natural gas. And the CIS, the old Soviet bloc countries, still have more than 60, about 70 years of reserve to production ratio in advance. So let's take a look at the history of that. So the big changer here is the Middle East. That's the orange line. Back in 1990, they had a reserve to production ratio of 400. That means that they had lots of natural gas and they weren't really using it. So they were pumping it back into the ground. So they had a very small production, so they had a very high reserve to production ratio. They've actually started using the natural gas now, and they've been pumping it out, and they've reduced their reserves down to a little bit over 100 years. In terms of proven reserves of natural gas, they've changed quite a bit. Back in 2000, we had 138 trillion cubic meters, and by 2020, that had increased to 188 trillion cubic meters. That means that exploration and fracking have increased the amount of known reserves of natural gas. If you look at the distribution of where that natural gas is situated around the world, it really hasn't changed much in the last 20 years. If you look at natural gas producers versus consumption, it's actually much closer to 1-to-1 than it was for oil. So in this case, most of the natural gas is being consumed in the region where it is being generated. The only real exception to this, for the most part, is the CIS, the old Soviet bloc countries that are exporting natural gas to Europe. And so CIS is a net exporter and Europe is a net importer. But what this really shows is that it's actually very difficult to transport natural gas long distances. Because it's a gas, you can liquefy it, but that takes energy and pressure and that sort of thing, and it's just not very convenient to transfer long distances. So where's natural gas being used at a high rate per person? Canada, the United States, Russia, parts of Europe, parts of the Middle East, Australia, New Zealand, basically, once again, the developed world. Europe actually, most of Europe actually doesn't use quite as much natural gas because their homes are older and they use different types of heating, not necessarily based upon natural gas. So where does the natural gas move around? Well, not nearly as much as the oil. We have a pipeline from Canada to the United States that we're importing natural gas from the Athabascan tar fields. We have the large pipelines that are going from Ukraine and other areas there towards Europe. That's the primary motion of gas. There also is some natural gas that's transported from the Caspian Sea region to China as well.